conducting this webinar today. So I'm going to talk about research opportunities, competitions, and startups. Uh, and again, sorry because I cannot see your instant messages. So I will just get on with the presentation. Okay. So pardon me that, because I want you to see this presentation than to see my face. Okay. So because this is more interesting. Sure. So what's the background? And I would simply put aerospace engineering with anything, aerospace engineering that deals with anything and everything which is mechanical, electronical, uh, a system that flies. Okay, so aerospace engineering deals with, it is it kind of encompasses everything and anything that flies. So may that be an aeroplane, drone, helicopter, or even a space rocket, space shuttle, or satellite. So space engineering or aerospace engineering deals with everything, and they make sure that a mechanical system takes off and stays in the skies or beyond skies. So that is basical, like that is the background of today. And so if you look at these pictures here, the first picture you will see, it might look like an aeroplane, but it's not. It is something with what we call UAV. It's a unmanned aerial vehicle. It can be as big as a small aeroplane, but it is basically control from the ground. It is controlled from the ground by people, by remote control. Okay, there is no person in it, and therefore the name unmanned. Okay, there is no man inside. The second picture you will see is it's a picture from a very interesting paper by NASA, and you really should look into it. And this is the second part we're going to look at, which is unmanned, which is urban air mobility. Now, because of traffic issues, because of noise pollution that is caused by traffic issues, and because of population growth, there is population growth. Because of population growth, there is a lot of vehicles on the ground, and in places like Delhi, Mumbai, Bangalore, you might be stuck in traffic for 1 or 2 hours. So people have come up with a very new concept called urban air mobility, which is another. They're thinking of airborne mode of transport. So there will be a small, basically let's call it air taxis. Okay, so there will be small drones. I mean, smaller than helicopters, not really small, smaller than helicopters. There will be drones which will be flying people from one place to another. Now, there are challenges. How, as interesting as this idea seems, there are a lot of challenges in this. So I'm going to quickly talk about what are the challenges. And from what I really believe in is, from challenges arises opportunities, and how we as engineers can leap on to those opportunities to maybe start our research career, maybe start a startup, or win competitions, or get better jobs. Okay, and the third picture, as you know, is a aeroplane. This last one is a helicopter. There is a drone, and this is a space shuttle. So these all things, or aircrafts, I should call them, come under aerospace engineering, and these are the products of combined efforts of all engineers, including aerospace engineers. So moving on, so the space sector, interestingly enough, is a combination of all the engineering branches, and that is where I want to really get into. That is where I want to get to. So there are IT and software people involved, making control systems for aeroplanes, for space shuttles. As you know, there is a famous picture from a lady from MIT who wrote, I don't know, some 100,000 pages of code to put the first to put the first man on the moon, right? So there is software people involved in space industry, mechanical people obviously, because they make structures, they make aircraft structures. Electrical and electronic product designers are really important as well. Those who are pursuing product designing or product design engineering or industrial engineering are important. The new set of engineers or scientists that have come recently in the space or are contributing to space sector are someone called data and AI engineers or robotics people from robotic branches. They do amazing job, creating algorithms, making systems that are not humanly possible. And finally, aerospace and aeronautical engineers. So, which is, that's what they do. They learn about aerodynamics. They uh, create structures, aircraft structure based on their knowledge of aerodynamics, make it more efficient, and so on and so forth. Why I think space sector is very important or very appealing or interesting or attractive is because there is a lot of money involved in the space industry. Space and aerospace industry worldwide is a $3 to $4 trillion industry right now, and it is more even for someone like me who has entrepreneurial mind and also into research and want to in future maybe have a startup in space sector is for me it is particularly interesting because there is private sector in the space industry which is booming, which was not there before 20 years ago. Now if a lot of you have seen, I don't know how many of you have seen or heard about it, SpaceX just launched their first manned mission into space yesterday. It was a great, huge success of Elon Musk. He's a big idol and role model for me. So his company SpaceX, of that $3 to $4 trillion, 38 to $40 billion stakes or share is of SpaceX. And Virgin Galactic is another big player in private space sector or aerospace sector, and they are about 15 to $20 billion industry. So, and I don't know how many of you are following the news lately in India, but recently, a week ago or 2 weeks ago, India has opened their doors. I mean, ISRO has opened the doors for private space sectors to come in and have their play or have their share. So you can basically now start something like SpaceX or something like Virgin Galactic in India, okay, if you wish to do so. And that is very interesting and appealing part of uh, this industry actually. There are challenges and so there are opportunities. So, and that is what makes it really interesting. So let us move on to something called unmanned aerial vehicles, and I want to show a really small video for you guys, uh, just to make this thing interesting. And I will so the drone industry is a very big industry. There are so many new players in drone industry, right? And there are so many new ideas and innovations that are happening in the drone industry. So people are using drones for ambulance services, okay, especially in parts of Africa where there uh, people where people can't reach and they can't send medicines. People are using that. Drones is a big part of event management industry as well. A lot of people are using drones for event management and event drones. So there is again opportunity in there. You might have seen in Tokyo, drones were used, right? Then rescue missions, drones are used for rescues. Drones is also used for surveillance. Okay, drones are used for delivery services. Amazon is putting a lot of money and time for their deliveries by drones, again because of traffic problems. I don't know if they are doing it now or not, but it is interesting. Again, you might see drones being used in agriculture. Agricultural drones are very, very famous in India. A lot of people are already using it, but there is a huge market for agriculture drones. One of the startup I am involved in is deals with agriculture drones in India. Okay, so I might, if you have any questions, do contact me later. People are using drones for cleaning. Uh, so there is one big building in UK called the Shards in London. Okay, it's a very oval shaped building. I'll just stop here. So there is a big building in UK called the Shards. So yeah, I'm just. So this building, I don't know how many of you can see. This building, the one time cost of cleaning this building is 5 crore rupees. Okay. So, and it takes 1 or 2 weeks to clean this building manually. Now, people have come up with cleaning robots and cleaning unmanned cleaning drones for um, to tackle this problem. So it's a I think 100 meter or something big, 100 or more meter big building, and people, those who clean it manually, have to climb up and support themselves by ropes and so on and so forth. So it's quite dangerous humanly. So people are thinking of drones as an alternative solution to clean the buildings. Now, clean the glasses basically. Also, a lot of people on the same lines. A lot of people are using drones for firefighting. Okay, yeah. Previously, it used to be used for it used to be done by humans, but again, it's quite dangerous. A lot of firefighters lost their lives, and now people are thinking of using drones or UAVs for firefighting, for cleaning. So there's a lot of opportunity in UAVs. So what is the key? Why UAVs are so important? It's because they are faster. Okay, if you use UAVs in anything, uh, there is one of my friend who is in Birmingham, UK, and he has a big IT company. He runs IT company there. He employs almost 400 people in Birmingham. So he called me the other day, and he told me that one of the ideas he's thinking of is to use drones for organ transplants. Right? What do they mean by that? What does he mean by that? Is that he wanted to use drones. Suppose somebody dies in, let's say, in a part of Pune by accident, or a natural death, and he wants to his family wants to donate the organ. So instead of going there with ambulance or something, you send a drone there. You send a local doctor there or local surgeon. Okay, you pay the surgeon to get the organs. You put it in the drone and you bring it to the main city hospital. It's cheap. It's quick, it's cheap, it's versatile. It's versatile. What do I mean by that? Because you can use UAVs for many, many different reasons. The one we see in videos. UAVs are mostly used by military for surveillance. Okay, they can't send a man with a small aeroplane. If somebody, let's say, we want to we want to do a surveillance in Pakistan, in Karachi, you can't send your pilot. Okay, because if it's found, then there will be a deadly consequences. So you just send a UAV, you take some pictures, come back in 2 hours, and then analyze them. That is also where your AI techniques come, and I'll talk about them later. So there are so many opportunities light that lie with the use of UAVs. Let's a little bit talk about urban air mobility, and that is a fairly new concept. And again, pardon me for doing this again, but it's just 1 minute video, and this will show you what is really mean by that. What do I really mean by that? So because there is urbanization happening and traffic happening, population is growing. Okay, uh, people are thinking about airborne public transport, and lot of big players are playing their role. For example, Airbus, uh, Uber, Google are developing their own urban air mobility systems. So one of the challenges with urban air mobility systems is that there's safety measures, right? Because you don't want to put a lot of people, let's say four people in a drone where there is no driver or pilot, and want to fly them from one place to another place, right? So that is one of the challenges. If you look at it, that um, you can tackle, right? So there is safety measures, and because it's at the end of the day a drone or a small helicopter, it makes a lot of noise, right? So noise is a very big issue, because these propellers, these fans make a lot of noise, and a lot of people, yeah. So lot of people are not happy with the noise. So again, let's talk about a little bit about why it is interesting, because it can be considered as a new mode of transport. There is a lot of interesting things happening. One of my research, PhD research, uh, this year, or for this PhD, is basically on developing urban air mobility models, urban air mobility drones, and I am particularly looking into how we can reduce the noise levels of those drones, because we tried them in London and New York, and people were not happy with the noise that was produced by these drones, by these passengers drones or air taxis. So that is one of the research areas we're looking into. But nevertheless, let's talk about why they're interesting. So they're interesting because they're new mode of transport. A lot of companies are in race against the clock among to establish their startup or establish their product in the market. Again, big players are in the game. Airbus, you will see Uber here, and safety and noise are another issues. So when you have time later, maybe look into Kitty Hawk and Lithium and Volocopter. Okay, definitely go on YouTube and see their models of how they think that air taxis should look and operate. Okay, so Volocopter, you will see, has 8 big rotors, 8 big fans. Okay, you will usually know two fans or 4 fans, but Volocopter has 8 fans. So you can imagine how big noise it can produce. But that also means that their taxi is more stable because it has more fans, and their air taxi will uh, be more stable and will have more thrust, and therefore will fly longer ranges. Okay, uh, that that brings me to my next part, which is what is the role of artificial intelligence in space, or in should really say aerospace industry. So we all know that AI is being used very at a very large scale in autonomous cars or driverless cars. We know Tesla, we know Google is developing their own, Uber is into trying to do the same. A lot of car manufacturers are into this autonomous cars, driverless cars, self-driving cars, and they mainly use artificial intelligence and algorithms, okay, um, for for their cars to operate. But something so similarly, how we can use artificial intelligence in space is what I'm going to look at today. Briefly, I'll tell you how we can use AI, and we can use AI to problem solve in space. So one of the problems in space, or when we launch satellite in in space, is a lot of us know that Chandrayaan 2 failed because it tilted, right? It tilted and it didn't land properly. So my project last year was, I mean, Chandrayaan was a very, very big space shuttle or space craft. My project was to look at how small a satellite, a satellite as big as your mobile, when it tilts or when it say changes its direction, how we can use artificial intelligence or algorithms to bring it back to its original position, right? So I did a project with European Space Agency, with and with the University of Manchester. I submitted my thesis for it, and I think we got it right up till until like 80% right. So we couldn't get it 100% because we didn't have at the University of Manchester, we didn't have uh, really high tech laboratory systems to test my product. But we tried with whatever we had, and it's a interesting project that I worked on. I might share the link or share my thesis with you later if anybody's interested. Another thing we use, another area we used AI in space is that there is something called, you'll see it here, NASA is developing shape-changing aeroplanes, wings. So, pardon me. So what is happening is the wing of the aircraft is what gives you lift. Okay, it is the one thing that lifts the aeroplane in the from the ground, right? And there is a lot of problems with the wing. Uh, and there are limitations because how the air flows over your wing. This yes, so how the air flows over wing and underneath or over your wing, it contributes a lot to contributes to a lot of drag and thrust, right? So and you, because if they're say, जसं मराठीत सांगतो मी तुला, जसं आत्ताच्या विंग्स, जसं सध्याचे विंग्स टेक्निक्स आहेत, तसं जर विंग आपण वापरलं, जे स्टर्डी विंग्स आहेत, ओके, तसले जर विंग आपण वापरले किंवा जे वापरतायत अजून लोक, त्यामुळे एक लिमिटेशन येतं की तुम्ही किती थ्रस्ट निर्माण करू शकता किंवा तुम्ही तुमच्या एरोप्लेनचा ड्रॅग किती कमी करू शकता. नाव थ्रस्ट इज इम्पॉर्टंट टू लिफ्ट द एरोप्लेन अँड ड्रॅग इज इम्पॉर्टंट बिकॉज जास्त ड्रॅग असेल तर तुमचं एरोप्लेनची रेंज कमी होते किंवा ते जास्त तुमचं फ्युअल इकॉनॉमी जी म्हणतो आपण त्याला, ती खूप कमी येते. तर सेफ चेंजिंग एरोप्लेन्स असल्यामुळे काय होतं की जशी हवा किंवा जसं विंड तुमच्या एरोप्लेन वरून जाईल, तुमचं एरोप्लेनचं विंग विल ऑटोमॅटिकली ऍडजस्ट इट सेल्फ, because it takes the data from the wind, takes the data of the pressure applied on the wing by the wind, right? And then it changes its shape so that the total thrust created by the wing is more, and the total drag created or the total drag induced on the wing on the aeroplane is less. ओके, दॅट इज व्हेन यू वॉन्ट टू लिफ्ट, जेव्हा तुम्हाला लिफ्ट करायचं असतं. आणि जेव्हा तुम्हाला लेट्स से व्हेन यू वॉन्ट टू कम डाऊन, ऑब्विसली तुमचा ड्रॅग जास्त हवा आणि तुमची थ्रस्ट कमी हवी, सो दॅट यू स्लो डाऊन. सो what the wing does is again takes the data of the pressures applied on the different parts of the wing, and then the wing will change its shape accordingly to reduce the thrust and increase the drag when you want to land, right? Now, why am I telling you these things? Because there is a lot of AI algorithms involved in it. That's one thing. Second thing is that a lot of metallurgical people or mechanical people and or IT software people can look into this problem, do some research, and if they have a great idea or if they have interesting solutions for this, they can directly hopefully talk to NASA. Okay, there was a competition 2 years ago. I don't know if that competition will happen again, but if it happens again, you can definitely jump into it, right? So this was the project. This is the NASA's project. Um, and the third thing is where we are, as I said, one of my friend is looking into uh, using drones for human organ transplant. Now, uh, this is a great startup opportunity, पहिली गोष्ट. आणि दुसरी गोष्ट म्हणजे this is also interesting engineering problem. Now, why is it interesting engineering problem? Is because, say, if somebody dies 60 kilometers away, right? You want to ask yourself, does your drone, whatever drone or unmanned aerial vehicle, has that capacity to fly, go 60 kilometers and come back 60 kilometers? So there are a couple of problems. So you're talking about range, okay? And that range essentially comes from the shape of the drone, okay, and the motors used and the batteries used. So you need to have a shape, maximum aerodynamic shape. दुसरं म्हणजे you need to have powerful uh, motors or propellers, and third you need to have a powerful battery. But when you have powerful motor, it's gonna eat a lot of your battery, drain a lot of your battery soon, right? So you compromise on range. So there is a problem for electrical engineers and mechanical or mechatronics engineers to come up with a drone design that is that is optimally efficient for these kind of services or projects. And how AI is introduced here is where I think you can use artificial intelligence to like create algorithms where you can basically create or give the drone shortest route possible. So every time when you fly a drone from particular location, it finds the shortest route possible. Then you can have an AI system in there inbuilt where as it's going, it's creating a map and it's sending the data to your system so that the future drones will follow the same route for the maximum efficiency. So these are some of the ideas I am working on. I'm working on this human drone, human organ drone. This upper wala jo image hai, that is how do you use artificial intelligence for self-correcting of the satellites, especially small satellites. Imagine they're like 1 kilo to 5 kilograms. They're not big. And then this is one of the interesting projects by NASA where you use artificial intelligence, where AI and composite material engineering and aerodynamics. You use this combination of three or four fields to come up with a maximum, to come up with a shape-changing aeroplanes, right? So this brings me to the final session, which is what are the opportunities. And again, this slide or the next two slides are just the overall summary. I'm going to summarize whatever I said, whatever are the challenges, and how you can turn them into opportunities in research, competition, and startup. So let's talk about research. So for those who want to really go into UAVs, and again, don't really mind, like don't be bugged by this word UAVs, because a lot of mechatronic engineers, a lot of mechanical engineers I know of, and a lot of people from other fields are as well are getting into UAVs and how they can make UAVs and drones give UAVs and drones a better future, right? So TU Delft in Netherlands, they have amazing PhD opportunities. You can get literally paid I would say around 20 to 25 lakh per year. Okay, to do your PhD for 4 years or 3 years, depending on what you want to do. Again, University of Bristol, this is where I am studying. They have some interesting projects in unmanned aerial vehicles and urban air mobility. Uh, I also been a part of team at Cambridge, which worked on how we could use artificial intelligence for UAVs. So there are opportunities in Cambridge, there are opportunities at Manchester, and opportunities at Oxford, mainly in AI in engineering, right? Um, so these are opportunities in research. You may, I didn't particular, I might, should have put some links in there because uh, I'm going to share this PowerPoint presentation with the organizers and they can share it with you later. I will edit it. I'll put the links in there so that you can see, right? And again, let's talk about competition because that is where you guys are, interested in. So there is something called Dyson Design Competition. Now, Dyson is a very, very well-known researcher and innovator, mainly entrepreneur, businessman in UK. He's from UK. He's called Sir Dyson. आणि तुम्ही त्याचे ब्लेडलेस फॅन्स किंवा डायसनचे हुवर्स किंवा व्हॅक्युम क्लिनर्स वगैरे बघत असाल. ओके, किंवा डायसनच्या खूप साऱ्या देर आर washing machines as well. So he does so many things. So and he conducts a competition on his website. I will again put a link there where you can build any product. You can be from any branch, by the way. You can build any product which solves the problem, and that is a very important thing here. A problem solving product that तुम्ही बनवलं. समजा, for example, if you really look into drones for organ transplant, and if you make that a viable business model, and if you make that also a sturdy product which really works, and if you win that competition, you can, anybody in the world can apply for that competition. You win around 30 lakh rupees, which is 30,000 pounds, and then his team will also help you set your business up. Okay, similarly, I forgot to mention, so I mentioned Virgin Galactic, आणि त्याचा जो फाउंडर आहे रिचर्ड ब्रॅन्सन, तो सुद्धा स्वतःची एक कॉम्पिटिशन घेतो आणि त्याचे सुद्धा प्राइजेस 10 lakh to 20 lakh असतात. Again, I will put that link there, and I know that because one of my friends from Brighton got selected for that competition. त्याबद्दल मी नंतर हे प्रोजेक्ट झाल्यानंतर बोलेन. Those who are interested in satellite designing, and again, don't be worried. You don't need a aerospace किंवा satellite designing badly degree to participate in this competition. But there is something called Cansat satellite designing competition, which is conducted by group of universities in UK, USA. Okay, you can enter into that and win prizes, get recognition. Very important. And then there is this something called German Design Awards. Now that this design competition is for product design, and it is similar to Dyson Design Competition, and any branch, any people can dive into it. Can, there is a registration link here. I think this competition is open for this year. Okay, and again, startup चं बोलायचं झालं तर again, anybody who wants to, because urban air mobility तसा न्यू कन्सेप्ट आहे, आणि जर कोणाला त्यामध्ये थोडंसं रिसर्च करायचं असेल, किंवा इफ समबडी हॅज इंटरेस्टिंग आयडिया, इंटरेस्टिंग कॉन्सेप्ट, मे दॅट बी मॉडेल वाईज, म्हणजे ड्रोन एक असा ड्रोन जो खूप सेफ आहे, नॉईज त्याचे कमी आहेत, किंवा you can come up with something like Ola doesn't have their own cars, right? They have a system, so you can have a system, right? Secondly, you can have a startup in drone delivery, agriculture drones, and event drones. भारतात इव्हेंट ड्रोन्सचा अजून फॅड नाही आहे, तर तुम्ही जर त्यात स्वतःला इन्व्हेस्ट करू शकाल किंवा त्यात काहीतरी तुमच्या नवीन आयडिया आणा, तर दॅट इज अमेझिंग. And finally, drone ambulance is again new concept. You can directly work with government of Maharashtra or government of India if you have a product and if you have a system. So these are the startup opportunities. And this is my time. I think मला वाटते थोडं जास्तच. Oh no, it's fine. We have 10 minutes, right? So contact me on here. And this is my LinkedIn. This is my follow me on LinkedIn. Follow me on Facebook. And that's it. Basically, I will. Yeah, sure. So if you have any questions, oh sorry, there are so many chats and I didn't. So Omkar says, is that easy to get anything started space technology like doing? Yes, it is very. It is very easy. Now it was not easy because मी स्वतः गेले मला वाटते ऑक्टोबर ते जानेवारी इंडियामध्ये होतो. And I met so many people. I went to ISRO Bangalore to ask about the startup opportunity in space, basically to work with to work with ISRO, to work with कारण माझ्याकडं I was thinking of a startup and I'm still thinking of a startup, and it was difficult then. But परवा Nirmala Sitharaman, I will probably share the link. I must have somewhere. She said that India has opened they have lifted a lot of the bans they previously had on the space sector. Okay, so you can get. I mean, getting government permissions will be very long procedure still in India, but they have, because they have lifted a lot of bans on the on starting with the space sector. I think that is that will be easier than before. Yeah, and Amey says, can you please share? Yeah, I have. I will share my. I'll share my. Uh, Presentation with you all. I mean, I'll share it with the organizers and they can send it to you all. Yeah, so you can have a look at it. So anybody has any questions can just let me know, give me feedback, or if you want to get in touch, I'll just share my details quickly on the chat. If anybody has, yeah, go on.
Hello everyone. If you have any queries or question, you can ask directly to the sir.
Yeah, so I'll just quickly talk about this. My friend who made a really small. I mean, जब तक हमें questions नहीं आते तब तक हम इस पे बात करेंगे. So there is
Hello
the
sir.
Richard. Yeah.
Yeah, sir. I have a question that can we implement that UAV and that urban air mobility and unmanned air vehicles in India,
Yes,
and
obviously
how?
India needs it. India needs it. Like there are some hot countries where it can work. Like China, it works. USA, in New York and London, UK, it works because there is a traffic problem. And where there is traffic problem, UAV, or let's forget UAVs, but unmanned urban air mobility concept is much essential in India. Now you just need to look at the regulation, laws and regulations around using drones and using UAVs. Okay, because they have been made very strict lately. Okay, but if you look into it and if you can get government permissions, I think India needs it more than anybody else, because there is nobody follows. I mean, I'll be exaggerating or not, but nobody follows traffic rules, and there is a lot of traffic, and people waste a lot of time in traffic, and because there is 2 hour long traffic jam. Imagine the air pollution that is happening in that particular area. So to mitigate that particular situation, I think yes, definitely you can approach the government of India, or you can have again, as I said, have a system, have a product, okay, and then go to a government agency and say, this is what we want to do. I think they will be very happy to receive it. If not, lot of angel investors, lot of investors are interested. or you can go to Sir Dyson and say a better product than Uber. Yeah.
Will it available now? Because uh, the economy is already down in these days due to the
I mean,
coronavirus. So
yeah,
can
yeah,
we?
sure. Yeah. I mean, you can't develop a product tomorrow and go, right? It will take a year. You can't do it in 1 month or 2 months, right? So it's gonna take to have a product, have a system. It's gonna take you at least 1 year or 2 years. So at least 1 year. So by that time, hopefully, economy will come back. Okay, so don't worry about like really corona and stuff. Um, but yeah, and Alias said, how developed is the UAV technology in UK? It's very very well developed. Although they are not using urban air mobility systems here in UK. Uh, Amazon is using drone delivery, or they have a small box that they are using robotic delivery basically. So there is a small robot. It's a basically a small car. Itna chota sa. Okay. Uh, I think half a meter by half a meter car, and they're trying to use that for the deliveries. Amazon, and then there is this big जैसे Reliance malls वगैरह असतात ना तसे in India we have sorry, in UK we have Tesco, Sainsbury. So they are using these drone deliveries or robotic deliveries in UK in some parts, again not all the UK. Would you let us know a bit more about AI in aeronautical engineering? Much into it. Uh, Again, as I said, aeronautical engineering, my people are using AI to for the thing we talked about is how do we know that how can we make a shape changing wing, okay, and that is very very important to increase your fuel economy and to uh, give you an edge, okay, especially in military uh, aircrafts, okay, that's very very important. So people are using AI in that part. I'm not I'm not really aware of any other things, but yeah, shape changing aeroplanes. Yeah. Any other questions? Yeah, I will share the links. Definitely share the links. Any questions? Yeah. So shall we, Aniket? Oh no, there is one more. No, that's
Two more questions are there.
oh yeah, there is. Can you guide us how to pursue aeronautical engineering? How you pursue? Oh yes. It was very, I mean, comparatively easy for me because I did my 11th and 12th in UK. So I was I prepared myself. I did preparation for IELTS. तब IELTS नहीं था, तब TOEFL था. Um, and then I just applied for universities. But it was mainly I got interested into aeronautical engineering because of we had a lesson about Abdul Kalam in our ninth grade textbook, CBSE English. So I joined, like I was really interested from ninth class to 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 pursue my aeronautical engineering. Then I wanted to somehow by hook or crook do that anyway. But there I didn't give any particular exams because other than TOEFL. Okay, so and I got easily really got into University of Brighton for aeronautical engineering, and I got the scholarship as well because I was good at physics, I was good at mathematics, and I had done work projects when I was in 11th and 12th to pursue. So I don't know if that answers your questions, but yeah. How developed is the obstacle avoidance system in? Yeah, just hold on, guys. Let me. How developed is the obstacle avoidance system in the present day drones to detect moving objects like flying birds? What are the opportunities in the subdomain? Yeah, interesting question, Harshvardhan. I exactly worked on when I was in Manchester. Worked on a project where we developed a bird-like UAV. जैसे a lot of you must have seen that movie. Uh, um, yeah, which was about surgical strike, right? त्याचा जो bird आहे ना, so we developed that bird, and there is a big pond in Manchester, and a lot of ducks used to live in the pond. Okay, and there, and in the middle of the pond there was this big island kind of small jungle, and ducks used to fly, like swim in the water, and then at the in the night, during night or in daytime, they would go back and stay in that small island. So the city council didn't know. Uh, so the city council didn't know how many ducks are there and what is the population of ducks. So we used the unmanned air vehicle. We fit in a camera there. We had a very sturdy AI system, and it would take couple of rounds of the pond, and it would detect the birds. Right? We did something like that. Uh, what are the research opportunities? There's two parts in here. So you could either go into there is something called biomimicking, okay, in engineering. So you mimic biological objects, or i.e., like for example birds, okay, and a lot of people are using this spiders, okay, also. So anything biological, how you can use them to kind of make your own system, isn't it? So there is, you can go into biomimicking, that's the first thing, or you can go into AI, or you can go in you can combine those both and come up with your own research topic. Again, University of Manchester, go and look into biomimicking or biomimicry. You can just type like biomimicry, University of Bristol or University of Manchester. You will find a lot of opportunities there, Harshvardhan. Can you suggest where should we start from? I think it will begin with uh, knowing a little bit, not a lot, a like very basic information about how aeroplanes fly. Okay, that is the basic thing. So once you get what is the length of your, how long should be your wings, how long should be your body, how does weight matter, right? Uh, and where should be the center of mass. If you get that right without any electrical systems, okay, if you get the basic understanding of flying objects or aerodynamics of a aeroplane, it is a very good place to start. And then once you get the understanding of the how big should be your wings and your length of your UAV, then you can add other components, like you can add battery, you can add propellers, you can add your own small computer, which is, or you can use Arduino, Raspberry Pi, and then you can make it turn and twist, okay, and then you can add a camera to do a surveillance. So it's a kind of step-by-step process, right? So I hope that answers your question, Saman. Can you let us know about your project you have been a part of, CubeSat? Okay, I think I quickly touched upon that question, where I made a very small satellite, and that satellite is a 10 centimeter by 10 centimeter cube, and that's why it's called CubeSat. Okay, and we made that satellite, and my part was to, again, as I said, it spins really fast in the, because it is going at the, let's say, 1,000 miles per second. And if suppose it's not in the correct orientation, it should go like this all the time, okay, because your camera is pointed at earth all the time, right? So if it changes its direction like this, your camera is not pointing at the place where you want to do it, and that just doesn't serve the purpose. So my project was, if your satellite is like this, and if it changes its direction, I developed a system, mechanical plus AI system, where your mechanical system pushes back on its original uh, content. That is one project, and the other project we worked on, again, as Aditya, is where we build a small satellite which is surrounding the earth, which was not, it's not no more doing that. because it worked only for 2 years, and it collected ozone layer data, and it collected where the ozone layer was, uh, you know, uh, it's getting damaged. Okay, and it is to send data to us, and we used to see like where the pollution is happening. So let's say if ozone layer on India or over India is getting thin, then that means India most probably is producing a lot of CFCs. So the good thing about that is we could then possibly use that data, use that uh, uh, pictures and data, and send it to government of India and say that, look, your country is not doing so well, your ozone layer is getting thin. Can you please do some, come up with some policies to avoid these problems? Uh, and this is how policies are made. So space technology is directly linked with policies that a lot of countries make. Some Shrikant says, how should I drive in research of increasing flight time of a drone? Uh, there are a lot of things that are involved in there. So let's say if you have a longer wing UAV, right? Just say longer wing aeroplane, it moves, it goes longer, okay, but it is slower. Like, so that's one thing. So it can go, um, the distance it travels is longer, but it glides really slow. Whereas if you have a small wing aircraft, it goes very fast, but then it doesn't travel as much if both of them are released at one point. So you need to come up with a, so how does it work is you need to define a purpose. What are you making your UAV for? Is it for a long range, or um, is it for short range and quick things, right? So if you want to do something like somebody asked, like surveillance, you need your UAV to circle around, or go over a longer distances, take a lot of pictures, collect a lot of data. So I think it all depends on what is your purpose, and then you optimize your particular flight or aircraft according to the mission. um, and there are basic things involved, like how, again, um, if for long range, use bigger aircrafts. For small range, for example, if you want them to go fast, if you look at any military, like our Indian Air Force aircraft, they're really narrow. Okay, they're really narrow. They have really small wings, and because they have small wings, they're going incredibly at fast rate. Whereas Airbus or a normal aircrafts have big wingspan, and that gives them more stability. पहिली चीज. आणि दुसरी गोष्ट म्हणजे they can go slow. Passenger aircrafts don't have to go as fast. So again, it depends all on your, to answer your question. Uh, how should I dive in research? I think you should define purpose. What are you, what is that you are into? Earlier to a startup in agricultural activities, how does a drone work in agriculture? Okay, that is interesting question, and I would quickly tell you. So there are two parts. One is drones, two is AI. So what happens in is that समजा तुमची एक एकर शेती आहे, आणि तुम्ही एक माणूस समजा त्याला फवारणी करण्यासाठी, मेनली फवारणीसाठी हे वापरतात ड्रोन्स. तर फवारणी करण्यासाठी एक माणूस वापरता, आणि ही टेक्स 1 day, and then his shoulders hurt, and then you have to pay him 500 rupees, or 1,000 rupees, whatever, right, फवारणीसाठी. Also, if he is lazy, he won't do it properly, right? Also, उसावर जर फवारणी करायची असेल तर, if the man is short आणि समजा ऊस मोठा असेल तर he can't reach the top of the top of the crop, right? So where you use the drones is to mainly to use it for sprinkling. Okay, fertilizer sprinkling, पहिली चीज. दुसरी चीज, how do you use AI in there? समजा तुमची शेती आहे, आणि तुमच्या पिकावर कुठेतरी कीड पडलेले, आणि you don't know where the particular pests are harming your crop, right? So what you do is your drone goes up, right? It takes the picture, okay, and you give them a, like you somehow create your AI system where तुम्ही समजा त्या किडीचं पिक्चर त्या AI सिस्टम मध्ये फीड केलं असेल तर then the camera or your AI system will recognize where the pests are actually in the field, right? So it will go and spray the fertilizers only where there is a lot of pests, okay, which human eye can't do. So human will spray everywhere, whereas you can have a drone which sprays only in the affected areas, saving you time, saving you uh, pesticides. Also, using a lot of pesticides are not good for obvious reasons, because they, at the end of the day, they will go in your stomach, and a lot of them are cancer causing pesticides. So again, uh, one drone, maybe it's like 1 lakh 2 lakh rupees. Not many farmers are interested to buy that, okay. दे विल से आम्ही एकदा 500 रुपये देतो आणि आम्ही आणि त्याच्यानंतर आम्ही हे करतो, काय करतो, वी विल, that's it. We don't have 2 lakh rupees to spend one time, but you can target big farmers, पहिली चीज. Secondly, you can have partnerships with sugar factories owners, okay, because कीटाणूंचा प्रादुर्भाव, ओके, अँड ऊसाचं जे पत असते किंवा येस ऊसाची पत is directly related. So if there is lot of pest, your sugarcane quality reduces, ultimately reducing the quality of your sugar. So lot of I am thinking, like, we are working or trying to contact with lot of sugar factory owners with that. So this is how agriculture drones and agriculture are important. What are the exact difference between pursuing PhD and Aerospace? Pursuing PhD is mainly research oriented. So in PhD, you don't go into classes and learn anything. You have to have your own. You need to read a lot. You need to come up with ideas. You need to perform experiments. It's 100% independent. Whereas MSc or MNG, you are taught 60-70% of is taught, and 30% तुमचा personal project असतो. So I think that is what the difference, and that is the difference in all PhDs. Okay, so once you do why do masters? It's because you get an understanding of what are the existing research gaps. ते तुम्हाला अंडरस्टँडिंग येतं, आणि दुसरं, and with that research gap or with the research idea, you go into PhD and then you pursue. So I think that is the difference, and that's not just in the aerospace industry. It's applicable in all engineering. And I hope that answers your question. So I think that's about my time. I would like to thank VIT and IEEE guys for this opportunity. Thank you all for coming and listening to me. I hope you got something out of it. So thank you.
Okay, thank you so much, Pravin sir, for enlightening us with so many different ideas. I'm sure all of you are now very well aware of all the research opportunities, startup opportunities. I think he has covered literally everything that has an introductory part in this field. So I have linked a feedback form here below, and please fill this form. It will help us to get some valuable feedback on how to conduct more such webinars. And once again, thank you so much, sir. You have answered all these questions patiently, and I'm sure a lot of these questions are lingering in everyone's mind, to be honest. So thank you once again, and all of you, please feel free to give your honest feedback. We'll be coming up with more such webinars through the weeks, and we will mail you the content that sir has shared with us, and he'll be sharing it as well later on. So thank you very much, everyone, once again, and we're looking forward to seeing you in all the other webinars that we have as well. Thanks a lot.
Thanks.